guys, sorry to interrupt your video. Just a quick plea, subscribe to my channel please. If you haven't done it already, subscribe. Tell your friends, subscribe. Thanks. The next part here is the part 2 of the video, which goes a little bit more in depth, but again, I find it quite interesting, so hopefully you do.
As we learned in Wheel Balance 101, all wheel assemblies are manufactured with inherent balancing flaws. The wheels and the tires both feature imbalances. When wheels and tires are combined to make a wheel assembly, the shared imbalance of the two products create an uneven weight shift when the wheel assembly is rotating. An uneven wheel assembly will hop and wobble when spinning around the axle of the vehicle. This is caused by two separate forces, called static imbalance and dynamic imbalance. The imbalance shown in the current example is known as a static imbalance and features a combined heavy spot or an imbalance to the wheel, noted in blue, and to the tire, noted in green. As the tire rotates, the centrifugal forces of the imbalance cause the wheel to hop when the heavy spot reaches the top of the rotation and causes the wheel to slip when it reaches the bottom of the rotation. This condition is known as wheel tramp. If left unchecked, wheel tramp will produce uneven wear patterns on the tires and cause a severe up and down vibration while driving at highway speeds. To correct this problem, a wheel weight of some type must be applied to the light spot, or the opposite side of the imbalance, in order to equal out the weight distribution of the assembly. With the wheel weight applied, the static imbalance is corrected, and the wheel assembly can now spin with perfect balance. Dynamic imbalance is characterized as being an imbalance on the outside and/or inside of the assembly as it rotates around the side center line, shown in our example as a green square on the outside of the center line. As the tire rotates with uneven weight distribution, the centrifugal forces of the imbalance cause the wheel assembly to throw the heavy spots outward when they reach the outermost points of the rotation. As the wheel assembly throws the heavy spots outward, a severe side-to-side wobble is evident. Dynamic imbalance becomes even more of a problem when there is an imbalance present on both sides of the center line. Sometimes these imbalances are side by side, and other times they are located at completely different locations on the tire. When at full speed, this wobble is known as wheel shimmy and becomes most evident when the wheel is being turned around a curve. At highway speeds, wheel shimmy can produce a severe side-to-side motion and do severe damage to vehicle suspension systems. To correct this problem, weight must be applied to the opposite side of the imbalance on both sides of the wheel assembly in order to equal out the weight distribution. This is shown on our example as two red squares, which turn gray when they are on the back side of the tire. With the weights applied, the dynamic imbalance is corrected, and the wheel assembly can now spin perfectly balanced. When discussing the causes of wheel imbalance, it is important to remember that there are two types of wheel imbalance, static and dynamic. A static imbalance is located on the outside of the wheel assembly circumference and causes the assembly to hop, known as wheel tramp. And a dynamic imbalance is located on the outside and inside of the wheel assembly side center line and causes the assembly to wobble, known as wheel shimmy. Most wheel and tire combinations are perfectly balanced when they leave the factory, but what causes them to become out of balance after the vehicle drives off the lot? The number one cause of imbalance is tire wear. As tires wear over time, the rubber compound used to manufacture the tire becomes worn. If the tires are not regularly rotated and rebalanced, they can develop uneven wear patterns, which causes the wheel assembly to come out of balance. Another main factor are driving conditions. When driving fast on uneven terrain, weights that are already on your wheels may fall off or slip, causing an imbalance. Running over the curb or hitting a deep pothole can also cause a wheel imbalance. Starting too quickly from a standstill or sporadic accelerations can even cause a tire to turn on the rim, changing its position. All of these conditions can lead to an unbalanced vehicle that experiences wheel shimmy and wheel tramp while on the road. There are many factors that cause a wheel assembly to come out of balance. Several of the most important ones are normal tire wear, driving terrain, and driving style.
That's the important part. So good. So now you can see. Now, one of the questions is, you're driving on the road, what can cause the wheel to vibrate? Improperly balanced wheels, because the weights on it aren't right, so it gets a vibration coming through the steering wheel. Now, this is a video mainly fired at lorries, but the same thing applies.
The effect of tires on fuel consumption.
Fuel consumption.
It's a scientific law of physics that to travel, you need energy. Most cars and trucks use fossil fuels to provide this energy. We all know that fossil fuels emit carbon dioxide, and carbon dioxide contributes to the problem of global warming. Therefore, it is essential to do everything we can to limit the harmful emission of carbon dioxide. In China, the government is setting targets for control. Compared with 2005, CO2 emissions per unit turnover of operating trucks should decrease 13% by 2015 and decrease 20% by 2020. Reduce fuel consumption and reduce carbon dioxide emission. It means lowering the impact of the forces that move the vehicle. There are 5 of these forces. Let's have a look at them in a little more detail. First of all, let's talk about inertia. Inertia is the act of changing the velocity of a given vehicle. Secondly, gravity. This is inescapable, as it is the link to the weight of the vehicle. Thirdly, aerodynamic force. This is becoming widely recognized, and vehicle designs are being adapted to start to overcome it. And fourth, let's not forget the effect of mechanical friction, the moving components of the engine and drive shaft. There is a 5th force, which is hidden and difficult to understand, but it is responsible for nearly 1/3 of the fuel consumption of the vehicle. Your tires actually consume fuel, so we must stop the thirst your tires have. Let's explain how. Under the weight of the load, a tire is distorted each time the wheel turns. This distortion causes flexing, compression, and shearing. It's essential for the grip and comfort, but as a result, it causes rolling resistance in return. The question is, why? Well, it's because tires are made from viscoelastic materials. This means once these materials have been distorted, they regain their shape only after a short period of time, and all the energy taken to distort the tire is not fully restored. This too is scientific law of physics. Some of the energy is transmitted and lost in the form of heat that warms up the tire. This loss is a good example of a major component of rolling resistance. If we take a closer look, rubber compounds are composed of long molecular chains and columns, and these are linked by chemical bridges, which give elasticity, strength, and rigidity. Rubber is often filled with carbon black and silica for resistance to wear, and heating occurs due to the friction between the molecular chains shown in this animation. If we adjust the composition of this complex chemical mixture, we can successfully reduce rolling resistance without sacrificing the other vital characteristics a tire needs. This means we produce tires that consume less fuel than those that we have made in the past. There are several other factors that influence the rolling resistance and hence fuel consumption of a tire. First, let's talk about air pressure. On the left, we are showing an underinflated tire, and on the right, we show a tire with the correct level of inflation. Under the weight of the load being carried, the underinflated tire on the left is far more distorted compared to the correctly inflated one on the right. As a result, the underinflated tire consumes more fuel. Now, let's talk about wheel alignment. The most critical alignment angle is the toe setting on the steering axle. Excessive positive or negative toe will cause scrubbing and shoulder wear to the tire and increased fuel consumption. Toe can be expressed as an angular measurement. Toe in is the term used when the leading edge of the 2 front tires is closer together, and toe out is the expression used when the trailing edge of the 2 front tires are closer together. Zero toe is the expression used when the wheels are parallel. For trucks, every 1 degree of misalignment will effectively drag the truck several meters sideways for every 1 kilometer traveled forward. The natural driver reaction is to keep the truck in a straight line by applying a small amount of steering input. This gives excessive flexing and scrub to the tire, consuming even more fuel. The important points that we've now learned in order to reduce your fuel consumption are as follows. Firstly, you need the correct tire that exhibits low rolling resistance. Secondly, you need to maintain the correct inflation pressure. And thirdly, to maintain the correct wheel alignment setting. Attention to maintaining these 3 elements, and also the avoidance of overload, with good driving habits will maximize your tire life and reduce your fuel consumption even more.
So wheel alignment, that they're saying there, that's when the geometry of the car, when you hit lumps and bumps, there's lots of bolts and arms that connect the wheels onto the car. And when you hit a lump or bump, sometimes it gets a jolt and something loosens and something goes slightly out. Now, if your wheel alignment is wrong and it's slightly off, like it said 1%, it's off, it's going to move you to the right, for argument's sake, over a kilometre. But if you're steering to the left to put it back, you're actually driving down the road steering left just to try and stay in the straight line. So your wheels are pointing that way to counteract the fact that it's naturally going that way, but you're going forwards. So therefore your tyre isn't rotating, it's actually scrubbing on the floor. And that's how we saw the tyres earlier on. If you look over here, look, here we go, look, these walls are bald on the insides, and that's where the alignment's out, but we're steering to the side, so we're actually just using the inside edges of the tyres. So that is an example of wheel alignment that they were talking about. And then finally, how to reduce tyre wear. You've got the idea by now, I hope. There we go. So a little video about the tyres and how to control them. So wheel alignment is really, really important, as is the correct tyre, the correct inflation, all the rest of it. Something else that can affect the tyres is if your brakes are a bit grabby. So i.e. when you put your brakes on, if they're like gripping the tyres, then what happens is your tyres will temporarily stop and skid down the road and then rotate again if your brakes aren't quite right. And also your suspension, which I'll come to on another video, which can cause the tyre to bounce. And of course, if your tyre's flying through the air and then lands, just like when an aeroplane lands, you see an aeroplane come in, and when the tyres touch, you hear that squeal and a puff of smoke that comes off the tyres. And that's when the tyres are going from 0 miles per hour up to 300 miles an hour, or whatever they land at, 150. And it's that sudden acceleration. As they touch the floor, you burn that little bit of tyre away. So if you're driving down the road and your tyre is bouncing, it's flying through the air and then landing, scrubbing and then bouncing again. So the suspension itself can cause premature wearing on your tyres. It's quite a lot of things to consider. But hopefully that will answer most of your questions regarding the theory test. So if you like what I'm doing, please subscribe and tell your friends, get them more and more people that subscribe, the better. Okay, hope that helps. Take care.